Math. All right. What is the probability of flipping a coin 3 times and landing on heads every time? So when we're doing multiple events, we call that compound events. So a lot of times we like to make a sample space, and a sample space is just a way to show all the possibilities. So let's say I could say I'm going to flip the coin and it's either going to land on heads or tails, right? Well, and I'm going to move this right there. Okay, so it's either going to land on heads or tails. Well, let's say if it landed on heads. The second time I flip it, it's either going to land on heads or tails. Well, if it lands on tails the first time, I'd have to flip it again, and it could land on heads or tails. Then, the second time I flip it, or excuse me, the third time I flip it, it's either going to land on heads or tails, heads or tails, heads or tails, heads or tails. So I know that I can have, if it's heads, what's the probability of flipping a coin 3 times and landing on heads every time? That is this guy right here. That's heads 1, heads 2, heads 3. That's the only time it happens that way. And this one right here, it's heads 1, heads 2, tails. So the way I would write this down, I would say, well, I've got one scenario that is heads, 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 right? Heads, heads, heads. Now I've got another scenario that's heads, heads, tails. Heads, heads, tails. I've got another scenario that is tails. Okay, so I was cut off by my video because we only do the free version here, and I this is my sample space, and I written down all my possibilities. So the way we figure out probability is favorable over possible, and I apologize for my horrible handwriting on this tablet. So the favorable is what would get me the criteria that I wanted, which was 3 times landing on heads every time. So which one was 3 times landing on heads every time? Let's see, that one was, and that's it. So I say 1 over, and then I list the possible outcomes. 1, 2, 3, 4, 5, 6, 7, 8. There were 8 possible outcomes. So the possibility of landing on heads all 3 times is 1 out of every 8 attempts. That's how we do that. So, pretty simple, right? Now, going on. What is the probability of drawing a jack out of a 52 card deck of cards? Well, so let's see here. We write favorable over possible. So what would make that favorable? Well, we've got to draw a jack, and I need to know how many jacks are in a deck of cards. And you may or may not know that, but I happen to know that. I play a lot of cards, and there are 4 jacks. Okay, there's the jack of hearts, the jack of diamonds, the jack of spades, and the jack of clubs. Okay, what's the possibility? We could pick any of those cards, so there are 52. So 4 out of 52 times, I'm going to get a jack, or that reduces to 1 over 13, right? But what about the probability of drawing a jack 2 times in a row after replacing the card you draw? Well, last time I did this, I made a sample space when I had multiple events, compound probability. So we had 3 times, so I made a sample space. Am I going to do that for this? Am I going to write down all the cards and count them all up? That seems awful. That seems horrible. It's a terrible way to do that. And you're right, that would be a terrible way to do it. I mean, we could do that and get the correct answer, but it would be very time consuming. And I'm looking for shortcuts, and I'm sure you are too. So, we're going to go back and see if we can find a method. Okay? Well, let's see. What is the probability of drawing heads on the first time? So I'm going to erase some of this over here, give myself some room so I can work this out. Okay? What's the probability of drawing heads the first time, or flipping heads the first time? 1/2. Well, what about heads the second time? Once again, 1/2, because this coin only has two sides. What about heads the third time? 1/2. Now look and see if you can figure something out. Hey, look, if I multiply the probability of the first attempt and the second attempt and the third attempt, what do I get? 1 times 1 times 1 is 1. 2 times 2 is 4. Times 2 is 8. And there's our shortcut. So we go back and we say, okay, what's the probability of drawing a jack 2 times in a row after we're putting the jack back in? That's important. We're replacing the card. So, well, the first time we said it was 1/13. We put the jack back in the deck and do it again. Well, the second time it's 1/13 as well. So that means the probability of drawing a jack 2 times in a row is 1 over what? You might know your square roots. 169 times. So that means that would happen if probability works out, and we know that it's just a chance. It is a 1 in 169 times that we have a chance, or that we have the probability of drawing a jack 2 times in a row. So that's very unlikely, but it's possible. Just very unlikely. Okay, here is the big question. Here's the bonus question. What's the probability of drawing a jack 2 times in a row without replacing the cards you draw? So I draw it out the first time. Well, the probability is 1 over 13. Well, if it's a jack, which was what we said it was going to be to figure this probability out, the second time, how many jacks are left? Well, they started with 4. If we chose it, one of those 4 jacks the first time, now we know that there's only 51 cards left. And how many of them are jacks? 3. 3 are jacks because we're assuming that we drew it the first time. So then we take our calculator and we multiply 1/13 times 3 over 51, which I happen to know reduces to 1/17, but that's okay. And I get 1 over 221. All right. Actually, I'm going to get 3 times that, and then it would reduce down to 1 over 221. I just have a calculator that reduced for me. So anyway, so if you don't replace the jack, you have 1 in 221 times. So it's a little bit harder if you don't replace the first card. So just letting you know, that's how probability works. And that's how we calculate things and make decisions and policy. So maybe I'm just a little bit of a history nerd, and I enjoy how we make decisions and things like that. But that you can use this in the business world, and that you do use this in the business world. You can use probability in a multitude of places. So anyway, I hope that helps this week, and I hope that helps you solve probability.